In this question, there is a wedge of mass 10 kg. This wedge has some mass of 10 kg, and there is a system of two masses A and B. A has a mass of 3 kg and B has a mass of 2 kg. They are connected with a light string, and this string goes over a pulley which is attached to the wedge. These masses are free to slide on the wedge, and if we will release the system from the rest, then this due to the motion of these masses, this wedge will also move. Now we have to find out the acceleration of the wedge. First of all, we have to predict the direction of motion of the wedge, and for that I can see that the heavier mass is 3 kg. So this A is heavier mass, and obviously it will go down and B will go up. Now if A and B are moving towards back side, which is negative x-axis, so to conserve the momentum of the system, this wedge should move in the front direction. So I'm assuming that the acceleration of the wedge would be in the front direction, and a wedge is moving with an acceleration of A. Now, in the case of moving wedges, we have to solve the problem in a shortest possible manner, because these questions are very lengthier questions, and for solving these questions in the shortest way, we have to write the equation of the blocks with respect to the wedge. So I'm doing that, and I'm writing the equations with respect to the wedge. So with respect to wedge, I can see that first of all I'm drawing the wedge. So this is the wedge, and this is the pulley attached on it. Okay, now if I draw this ball A and this ball B, I'll see that there will be a normal reaction N1, which is acting in the upward direction on this ball, and N2 will be acting in this side on this ball B. This is N2, and the pseudo force will be acting in the backward direction, like that, and the pseudo force will be 3A on this ball, and it would be 2A on this ball. Now I can see that this force will be 30 sine 45, and this force will be 20 sine 45, and all the angles are 45 degrees. So if I write the equation in this direction for ball A, so for ball A, N1 plus 3A cos 45, it doesn't matter that I'm writing cos 45 or sin 45, because all the acute angles are 45 degree in this case. That would be equal to 30 sin 45. So N1 will be equal to this 30 sin 45, 30 minus 3A by root 2. First equation. Okay. Now, if I write the equation for ball B, it would be N2 plus 2A sine 45 degree will be, N2 will be balancing 2A sine 45 as well as 20 sine 45. So N2 will be equal to uh, 2 plus 20, in fact 2a plus 20 by root 2. This is the value of n2. This is the equation number 2. And now I am drawing the free body diagram of the wedge. So for wedge, I can see that this is the wedge, and if wedge is applying these normal reactions on these balls, so these balls will be applying the same normal reactions in the opposite directions on the wedge too. So this will be normal reaction N1, and this will be the normal reaction N2. Okay, now a wedge has a mass, I think it has a mass of 10 kg. This is 10 kg, and the force, we have to resolve the N1 and N2, and wedge is moving with an acceleration of a in the right hand side direction. So now I am not standing on the wedge. This is with respect to ground. Okay, now I can write the equation that n1 by root 2 minus n2 by root 2. I am taking only those components of n1 and n2 which are in the horizontal direction, because the motion of the wedge is in the horizontal direction. So n1 by root 2 minus n2 by root 2 will be equal to 10a. Now n1 minus n2 will be equal to 10 root 2a, and I am putting the values of n1 and n2 from equations 1 and 2. So n1 will be 30 minus 3a by root 2. So it is 30 minus 3a. I am taking that root 2 on the right hand side of the equation, and this is 2a plus 20. In fact, this is 2a plus 20 is equal to this 20a. Okay, now this is 30 minus 3a minus 2a minus 20 will be equal to 20a, and 10 will be equal to 25a. So the value of a will be equal to 10 by 25, which is 2 by 5, which would be 0.4 meters per second square. But I think that it is being asked in centimeters per second square. So the correct answer in centimeter per second square will be 40 centimeter per second square. So this would be the correct answer of this question. Okay, this was a lengthier problem, and I hope that you are able to understand this problem in a easier way. And there is also another method of a conventional approach in which we are solving this question in the frame of reference of ground, but it would make this question a very lengthier one, and it would be a very disappointing situation that at the end of the question you realize that you are not able to solve it after so much of effort and pain. So try to do these questions in the frame of reference of a moving wedge. This would make the problem to be easier. Thank you. I'll be bringing these kind of problems more in next videos. Thank you. Hello guys, welcome back on our website Unique Concepts of Physics, UCOP. And we also have our YouTube channel, and you can watch the demo videos there. Now in this video I am bringing the wedge pulley problems. These are one of the most complex questions of Newton's laws, and most of the children find these problems very complex, and they give them nightmares. So I am telling you the most easiest way to solve these kind of problems quickly with minimum efforts. And in these problems it is very important to see motion which is constrained motion. That in this question particularly you can see that this is a hinge which is attached with a string which is going over these pulleys, and this string is attached to a block of mass small m on the other side. These pulleys are attached to a wedge of mass capital M, and this by the course of natural motion, this mass m small m will go down, and due to its downward motion, this wedge will move towards left. Now we have to find out the net acceleration of mass m with respect to ground. In this question it is mentioned that you have to find out the acceleration with respect to ground, but if it was mentioned that you have to just find out the acceleration of mass m, that also means the net acceleration, which is the acceleration with respect to the ground. So in these kind of questions, firstly you can write down the tension forces. This is T, this is T, this is T, this is T, and this is T. Okay, now let us assume that this mass m is going down with an acceleration a1, and this wedge is moving towards left with an acceleration a2. So first of all, we can write down the constraint motion relation by T dot A method. And we know that for these kind of constraint motion relations, the summation of T dot A for the system is 0, because tension is an internal force of the system and the work done by the tension is 0. So we can say that T into A1 with a negative sign, because T and A1 are in opposite directions, plus T, this one, into A2 with a positive sign will be equal to 0, which will give you a conclusion that A1 will be equal to A2. You need not to write this again and again, this equation. You can see directly that in the direction of motion, there is only single tension T acting on this mass small m, and there in the direction of motion of wedge is moving on the horizontal plane, so there is only a single tension T acting on the wedge. So you can directly identify that if the same tensions are acting on the blocks in the direction of their motion, then their accelerations will be equal to each other. So let us assume that these A1 and A2 are equal, and it is equal to A. So I am writing them as A. Now you can also see that in these kind of problems, in the horizontal direction, this block of mass m and this wedge will move together. It is very important fact to note that they both will move together in horizontal direction. This system will move together in horizontal direction with the same acceleration. So considering this fact, we can write the equation of the system. For the system, by system I am referring to m plus m, moving in horizontal direction. The equation will be that the tension force T is pulling this system towards left side, and therefore T will be equal to m plus m into A. This is the first equation. And the equation for this block of mass m will be that this block will be going downwards, and therefore mg minus T will be equal to ma. Okay, now if we substitute the value of T in the equation number 2, so substituting this value, we get that mg will be equal to 2m plus m into A, and A will be equal to mg upon 2m plus m. This is the acceleration A. Now we are being asked about the net acceleration of block of mass small m. Therefore this block is moving in x-axis along with the wedge with the acceleration a, as well as it is moving in downward direction with an acceleration a. So its net acceleration a net will be equal to root 2a, and this will be equal to root 2 mg upon 2m plus m. So this is our final answer. Okay, now we move on the next similar problem. Hello guys, now this is another problem which is based on the wedge pulley systems, and in this case you can see that there is a rope which is attached to this pulley, and this is passing through this pulley, and it is attached to this mass m on the other side, and this pulley is attached to this wedge whose mass is equal to 2m, and the angle of inclination of the wedge is 37 degree. Now if we release this system from rest, then we need to find out the accelerations of this mass capital M and small m. Now starting from the basic, that first of all we have to write the tensions. This is T, this is T, this is T, and this is T. Okay, now this angle will be theta itself, and the component of tension along this line will be T cos theta. Now let us suppose that this block of mass small m is moving up the inclined plane with an acceleration a, in fact a1, relative to the inclined plane. This is the acceleration of this block of mass m relative to the inclined plane, and inclined plane is itself moving towards left side with an acceleration with respect to ground, which is a2. Okay, so a1 is the acceleration of block with respect to the inclined plane, and a2 is the acceleration of inclined plane with respect to the ground. Okay, now if we write the constraint relationship of summation t dot a is equal to 0, then we realize that there is a force, this T, and the component T cos theta, which is acting on the wedge, and T minus T cos theta into A2, and plus T into A1. In fact, we can assume that this block will be moving downwards. Okay, so this will be, there will be a negative sign here. This is A1, that would be equal to 0. So A2 into 1 minus cos theta will be equal to A1. This is the first equation. Now second equation, when we write the second equation, we can make the free body diagram of this block of mass n with respect to wedge. So with respect to wedge, the free body diagram of this block its mass is m, tension T is acting on this block, and this is mg sine 37 degree. This angle is 37 degree, and its acceleration is in the downward direction a1 with respect to the wedge, and there will be a pseudo force acting on this block in right hand side, which will be equal to ma2. Okay, now if I write the equation of this block, in this will be the normal reaction n, and this will be mg cos 37 degree. Okay, now this angle will be 37 and this angle will be 53 degree. So this angle will be 53 degree. So I can write the equation that n plus Ma2 cos 53 is equal to mg cos 37 degree. Okay, and mg sin 37 degree plus ma2 sin 53 degree minus t is equal to ma1. Okay, so now the value of normal reaction is n is equal to mg cos 37 is 4 by 5 minus ma2 cos 53 is 3 by 5. So this is the value of normal reaction. Now for inclined plane, this is the inclined plane. The normal reaction will be acting on this inclined plane in the downward direction like that, n, and this inclined plane will be moving. This is 37 degree. So this this component will be n. This is 53. So this component will be n cos 53 degree. Okay, and there will be a tension force also which is acting on the pulley. It is T minus T cos 37 degree. So the equation will be T minus T cos 37 degree plus n cos 53 degree will be equal to 2m a2. Okay, now this is T into 1 minus cos 37 is 4 by 5 plus n cos 53 is 3 by 5 is equal to 2m a2, and this will be T by, in fact, T plus 3n is equal to 10m a2. Okay, this is 1 by 5t and this is 3 by 5t, 3 by 5n. So t plus 3n will be equal to 10n m a2. Now if I substitute the value of t and n from the previous equation, so t will be t from this equation will be equal to mg sin 37 plus ma2 sin 53. mg sin 37 is 3 by 5 plus ma2 sin 53 is 4 by 5 minus ma1. Okay, this is t plus 3 times of n. N is 4 mg by 5 plus minus 3 by 5 ma2. 4 mg by 5 minus 3 by 5 ma2. This is equal to 10 ma2. Now if I simplify this equation, this is 3 by 5 mg and this is 12 by 5 mg. So it would be 15 by 5 mg, which is equal to 3 mg. And plus this is 4 by 5 ma2 and this is minus 9 by 5 ma2. So it would be minus ma2 and this will go on the right hand side of the equation, and here it will be 3 mg is equal to 3 mg plus minus ma1 will be equal to 11 ma2. Okay, and the relation which we have already calculated between a1 and a2 is a1 is equal to a2. a1 is equal to a2 into 1 minus cos 37. Now cos 37 is 4 by 5, so A1 is equal to 1 by 5 of A2. A1 is equal to A2 by 5. So A1 will be equal to A2 by 5. So 3 mg will be equal to 11 m common A2 plus A1 is equal to A2 by 5. This is A2 by 5, and I'm taking out this m, and this will be 11A2. Now 3 mg will be equal to, in fact 3g will be equal to 56A2 by 5, and A2 will be equal to 15g by 56. This is the value of A2. Now A1 will be equal to A2 by 5, and A2 is this, so it would be 3g by 56. This is the value of A1. Now if we need to write the acceleration of this block with respect to the ground, so the acceleration of this block with respect to the ground will be, it has an acceleration of A1 down the inclined plane. This is A1, this is A1, and this is A2, and this angle is 180 minus 37 degree. So its resultant acceleration will be A resultant, and A resultant will be under root of A1 square plus A2 square plus 2A1 A2 cos 180 minus 37 degree. So by putting these values in this equation, we can get the value of the resultant acceleration of the block. In the next video, I'll be bringing more such questions which are based on wedge pulley systems. Thank you. Hello guys, now in this question you can see that there is a system in which there is a wedge of mass m dash, and there is a block which is kept on the wedge. The inclination of the wedge is theta, and this wedge is connected with a rope which is passing over the pulley, and the other end of the rope is connected to another mass, capital M. Now we can assume that this mass of capital M will go down due to its mg, and due to that this wedge and this block will move towards right hand side. Now we have to find out the minimum value of this mass m so that this block does not slips on this wedge. Okay, so we know that this block will not slip on the wedge only due to the pseudo force which will act on this block, and if we assume that the acceleration of this wedge is a in this right hand side, and the acceleration of this mass m is a in downward direction, then let us suppose that the tension is T in the rope, and the equation of this mass m will be mg minus T is equal to ma. This is the first equation. Now for this wedge we are assuming that these two objects, this wedge and this block, are moving together, and this is the condition that this block should not move relatively to the wedge. So we can assume that they are moving as a system. So the tension force is acting on the system towards right side and hence we can write the equation as T minus 0. For the complete system there is no force which is acting in the left direction. So T minus 0 will be equal to m dash plus m into a. Okay. Now, by these two equations, we can find out the value of acceleration, and we are still having one variable m in the equation, which we will get after adding these two. So, adding 1 and 2, we will get that mg will be equal to m plus m dash plus m into a. Okay, now this is the first equation, and a from this equation will be mg upon m plus m dash plus m. Now we have a condition that this block of mass m should not slip on the wedge. So we are now using that condition. So we can say that with respect to wedge, there is a pseudo force. Let me draw the diagram. This is the wedge, and here is the block which is kept on the wedge. The mass of the block is still m, and there is a pseudo force acting on this block in backward direction. Backward is due to the fact that this system is moving in forward direction with acceleration a, and I am writing with respect to wedge. So this is the pseudo force whose value is ma, and this wedge is frictionless also. The component of this pseudo force in upward direction, in this direction, will be, this is theta, this is ma cos theta, and the force which will make this block slip down will be mg sin theta. So if ma cos theta balances out mg sin theta, then this block will not slip on the wedge, and a will be equal to g sin theta. In fact, g tan theta. Now we equate this value of a with the value which we have already calculated, that g tan theta is also equal to mg upon m plus m dash plus m. So this mg tan theta plus m dash g tan theta plus mg tan theta. In fact, we can cancel out g with the other one. This m, this we are cancelling out, and this is equal to m. So for solving for m, we can see that m 1 plus tan theta is equal to m dash plus m tan theta. Now m is equal to m dash plus m tan theta upon 1 plus tan theta, and we can rewrite this. This is with the negative sign. In fact, here will be a negative sign. This will be a negative sign, and therefore this will be a negative sign. Okay, now m will be equal to m plus m dash plus m upon 1 minus, in fact, cot theta minus 1. So this is the required answer. Now we move on the next question. Hello guys, in this question you can see that there is a wedge C which is fixed, and there is a system containing a block A and block B of same mass, and this A is restricted to move with block B, you can see in the diagram. So this is understood that this A and B will go down the incline with a same acceleration. This is understood. So let us suppose, first of all, the tension in the rope is T and this is also T. Okay, this is T and this is also T. Now we can assume also that this A and B will move combinedly with an acceleration A along the wedge in downward direction. So if we are writing the equation of this system of A and B in the downward direction, we can see that there will be a force of 2 mg sine 37 which will be acting in downward direction minus tension minus T, and this will be equal to 2 ma. This is the first equation, and let us put the value of sine 37 also, that 2 mg sine 37 is 3 upon 5 minus T is equal to 2 ma. This is the first equation. Now for block A, we can see that if we are assuming that this system is going downwards with an acceleration of A, then this block A will also go upward with an acceleration of A, and this conclusion I have derived from the equation of constrained motion T dot A. You can write T dot A for block A and B, you will get this relation. Okay, now these accelerations will be same, and therefore I am writing the equation of block A as T minus mg cos 37. Mg cos 37 will, T is acting like that, this is T, and mg cos 37 is acting like that, this is mg cos 37, and it is going in the upward direction with an acceleration of A, so it is equal to ma, and T minus mg cos 37 is 4 upon 5 is equal to ma. Now if we add up these two equations 1 and 2, so we will get 6 mg upon 5 minus 4 mg upon 5 will be equal to 3 ma. This is equal to 2 mg upon 5 and it will be equal to 3 ma, and cancelling m with m, so A will be equal to 2g by 15. This is the acceleration of the system down the incline. Now we can see that this block A, I am drawing that block A. This is the block A, and we can see that the block A has two accelerations. One is like that, this one is A, and one is like that along the incline, this one is A. Okay, now therefore the resultant acceleration of A will be somewhere like this at an angle of 45 degree. This is A resultant, and A resultant will be equal to root 2 of A. Now A is equal to 2g, so it would be 2 root 2 and value of g is 10 upon 15. So A resultant will be this is 4 root 2 upon 3, and 4 root 2 can be written as under root of 32 divided by 3. So the value of x in this expression will be 32. So this is the final answer. Now let us move on the next question.